Hey folks, welcome back to EarthSky. I am Dave Adalian, and my guest today is Jonathan McDowell. He is currently of the Smithsonian Observatory and an expert on space launches and satellite re-entries and all things orbital. He keeps a keen eye, let's say, on the human presence in space, especially the goings on near Earth. And he's here today to talk with us about the growing number of falling satellites and how worried we should be about it. Jonathan, thank you for joining us, sir. How are you?
Great to be here.
So let's set the stage. How many objects, give or take, are in low Earth orbit right now? LEO is the
something of the order of 20,000 objects that we track orbiting the Earth. That includes 12,000 working satellites, and then a large number of dead satellites, dead rocket stages, and then smaller than that, too small for the radars to track, there's maybe 1 million centimeter size fragments also orbiting the Earth. So it's getting pretty busy up there.
It is getting quite crowded. And we've seen a few social media posts lately with videos of satellites. Specifically, we have seen SpaceX Starlink communication satellites coming down. This is one falling over Sacramento County in California. It's a very populous area of the state. We've seen a lot of these. I think people want to know, what are they seeing? Is there, and if there is a risk, and how immediate and big might it be? And where do we go from here?
Right. Well, we're seeing a lot of reentries, and in particular, SpaceX's Starlink constellation, which is now the bulk of working satellites. These satellites work for a median of about 5 years, and then they retire them. They lower their orbits down to a certain point, and then the atmosphere drags them in the rest of the way, and they re-enter at an unpredictable location. These satellites are not small. They are 30 meters tip to tip, the latest ones. They're a good fraction of a ton. And so as they try and fly through the upper atmosphere, they heat up, melt, break apart, and you get this very impressive fireball with independent chunks of the satellite streaking through the sky. When you see something like that in the sky, if it just goes whoosh really fast, then it's just a natural meteor. But if it takes, a minute or two to cross the sky in a more stately way, then that's a breaking up satellite. And you're seeing it's sort of misleading, right? Because what you're seeing is fireballs around the molten metal that are about 60 kilometers up, say, so 40 miles up. And so it's much higher than a plane. It's like 4 times higher than a plane. And so even though it doesn't seem to be, it often looks like it's going about the same speed as a plane, but it's really going much faster because it's so much further away. And it's much bigger than you think, and much it stays visible for a long time because it's so high up. It's visible for many hundreds of miles around. But the good news is that the Starlinks are designed to completely burn up. Now, we're not sure we really believe that they completely burn up, but at least for the most part, they melt. They contribute molten metal to the upper atmosphere, which may or may not be a great thing. But they don't come down in huge chunks to the surface of the Earth. Some satellites do. And just a week or so ago, we had a Chinese rocket stage that was launched from, I think, Xichang in China. And at the end of its first orbit, it deployed its satellites, and then it fired its engine again to lower into the atmosphere. And the fuel tank from this rocket stage, the empty fuel tank, survived re-entry and landed in a field in Argentina. And it's about a 3 foot across chunk that just fell out of the sky at maybe 100 miles an hour and landed, fortunately not on anyone's head, but there's clearly a risk there. And so we've been having chunks of that size, of sort of, meter size, several feet across size, pieces of hardware falling from the sky at terminal velocity for 60 years now. And we've been really lucky that no one has been seriously hurt. And so, but at some point, especially as we increase the amount of junk coming down from the sky, our luck is going to run out and someone's going to get hurt. So we do need to address this, I believe.
Okay. So you did mention that Starlinks are supposed to burn up entirely. Others won't. How many reentries are we seeing on a daily basis right now? And how is that going to change as these mega constellations are put into place? Starlink isn't the only mega constellation. There are two other Western commercial efforts at least, and then the Chinese have something planned. Is that it? Is that all?
Well, it's hard to tell how many are planned, are just PowerPoint, and how many are really gonna happen, right? There's a lot of ambition in the commercial space business, and you don't always get the follow through. But we are seeing. So I prefer to concentrate on what we're actually seeing get launched. So Amazon has their constellation that's going up right now. They've only launched 100 or so satellites to date, but they're planning thousands. China has two separate constellations, each of which is at least advertising they're going to go for tens of thousands of satellites. And one of those has launched over 100 already. There's a company called eSpace that's only launched about 9 satellites so far, but they claim in their filings with the ITU that they want to launch several 100,000 satellites. We think they're kind of kidding, but they don't have the capability to do that. But they're trying to just, seize the turf. But certainly they intend to launch a lot of them. And so we are seeing a variety of companies that are actually building hardware and shooting into space and building up these new constellations. So it isn't just Starlink anymore. The space is going to get really crowded as a result. So even before that, we have, not even counting Starlink, we have a couple of satellite reentries a day. Usually they're quite small, like CubeSats, and burn up completely. A couple times a month, we have a larger satellite, a non-Starlink satellite that re-enters. And so every few months, there's a report of a piece of space hardware that's re-entered that ends up on the ground as a significant piece of debris. So that's the sort of rate you're talking about. So several times a year, we're taking these pot shots at people on the Earth, and fortunately so far missing. And so that's
so far we've been very lucky.
So far we've been very lucky, but it won't last. In particular, there were some Chinese rocket stages that were 20 tons that they let re-enter uncontrolled, and huge chunks of them landed. One in Borneo, one in Côte d'Ivoire in West Africa. And just narrowly missed populated villages, and so there's real reason for concern that we see other operators being responsible and putting rocket engines on their satellites that deorbit them under control, so they come down in a targeted area in the ocean, and that's a much better thing to do. But we need to see more of that and less of the I probably won't hit anyone kind of attitude.
Okay, so we're beginning to study the compounds that these re-entering satellites are leaving in the atmosphere, specifically, especially rather, aluminum oxides. What do we know about how those might affect the atmosphere, the upper atmosphere? The mesosphere, I think, is particularly at risk, you say. Right.
The mesosphere is that upper layer of the atmosphere that is just at the edge of space, if you like. It's really thin. There's not a lot of it. And so it doesn't take much input to change it. And so my colleagues who understand atmospheric chemistry, I do not, are running the codes to try and see what effects this will have. So my limited understanding is that, yeah, the aluminum oxide particles can change the albedo of the Earth, that's to say the Earth's reflectivity, how shiny it is, and that can determine how efficiently we radiate heat back into space. It can contribute to warming of the atmosphere. There's also the shock waves it's not just the materials that the satellites are made of. When they come in, they have a shock wave that compresses the atmosphere, and chemistry happens in the atmosphere and makes pollutants like oxides of nitrogen. And so, you know, it's not clear yet, really, whether even in the age of the mega constellations, if these effects are going to be big enough to be really problematic. But it's not effective. It's not clear that they won't. And so that research is underway right now. If it comes back that, yeah, we're already doing damage to the atmosphere this way, we're going to have to rethink some of our disposal strategies.
That sounds true. So if satellites are coming down every day, that means more are going up. And we talked already about how crowded Earth orbit is getting. Are we close to some kind of tipping point in low Earth orbit where we're going to lose access to it, or it's going to become markedly more difficult to stay in orbit safely? Well,
that's right. And of course, the big worry is the famous Kessler syndrome that Don Kessler, orbit expert, warned us about back in the 1970s, where if you start having too many uncontrolled satellites whizzing around, they can hit each other so often that the debris from one collision will then go and hit other satellites and cause more collisions and more debris, and you get a chain reaction. And we're not far off that in some parts of space. Now, this is not such a worry with the mega constellations at the moment, because the mega constellation satellites are under active control. They're dodging each other. And so the simple math of what's the probability they hit each other doesn't work that way. On the other hand, if you were to have some event, like a big radiation event that knocked out, say, 10% of the satellites in the mega constellation, then that could get very bad very quickly. And so there is reason to be concerned. And even without that, the old rocket stages and dead satellites from the older part of the space age are still up there, particularly in the region of 600 to 1,000 kilometers, where they stay up for centuries because there's not enough atmosphere to bring them down. And it's crowded enough that the risk that they will eventually start this chain reaction is significant.
Okay. So you're talking about the ability to move. So there must have been a lot of close calls already with these things, with the Starlinks and the other mega constellation satellites that are going to be going up. Have we seen a lot of that?
Yeah, we see a lot of maneuvers by these satellites, like tens of thousands per year now of maneuvers by the Starlink satellites, mostly to avoid each other. Now they've set a very conservative setting, right? Most of these maneuvers are false alarms. If they didn't maneuver, they probably still wouldn't hit. And one of the problems is that because of space weather, because the sun makes the density of the atmosphere fluctuate, you don't know how much headwind the satellite is going to be going through over the next day. And so you don't know exactly where it's going to be a day from now. And so you can't say this satellite will miss my other satellite by 20 yards. You say, well, where it is a day from now, it's going to be 20 yards from the other satellite, plus or minus 100 yards. And so it might hit. And so because of that big uncertainty, you got to do a lot of false alarm dodging. and that's a real challenge right now, and increases the cost of the satellites because you have to carry more fuel, and you at a certain point, right, when you have even more satellites, you're going to have to worry that by dodging one, you might put yourself in the path of another, and especially if multiple satellites are dodging at once. And so there's going to be a point at which this regime just isn't tenable anymore, and there's got to be a limit on the number of satellites you can safely operate in these low orbits.
Wow. So, and I assume that all these various operators, I assume that there's so many thousands of these maneuvers that the computer is having to handle that. I don't know. But do they talk to each other about this? I'm going to make a move. Is there any kind of traffic control system?
I wish. No, yeah. So what we really need is an international space traffic control. What we have is the U.S. Space Force. And so the U.S. Space Force will look at everybody's satellites, and then if they see that two of them are going to come close to each other tomorrow, they will, if they happen to have the emails of the owners, email the owners and go, hey, you guys, one of you might want to move. And that's the best that it gets right now. Now, SpaceX have a WISO system where they upload the Space Force satellite catalog every day and use it in their onboard computers to compare the satellite. Their satellite knows where it is, and they kind of compute, am I going to hit any of the other satellites in the catalog? And so that much is automated. The trick is that the Space Force catalog isn't perfect, and there are things that are not in it, and there's data in it that's wrong. And so there is some chance that relying on this method is not going to be good enough to make you dodge all the potential collisions. So we're moving forward from where we were, but it's still a pretty hairy situation when you have all of these thousands of satellites all going at 17,000 miles an hour in all directions in 3 dimensions, and you want to make sure that they don't hit each other. It's not an easy problem.
No, it certainly isn't, and it sounds like we're going to have to do some international diplomacy to settle this, and probably right quick. There are other things going on with all of these, the number of satellites. They don't just affect space, they change how we see the sky. You already mentioned the albedo, but astronomers are reporting hundreds of bright satellites in telescope images. And how big a problem is that really for ground-based astronomy?
Right, it's a potentially big problem in the future. And so what happens is you're observing the sky, you may be taking a 1 minute long exposure. During that time, for a few seconds, the satellite whizzes across your field of view and it leaves a big fat streak of light on your photo. And if that happens occasionally, and the trick is for professional astronomers, right, we're not just trying to make a pretty picture, we're trying to measure the brightness and dimensions of stars to very high accuracy. And so it doesn't take much to screw the quality of the image for that scientific purpose. And so, yeah, as long as that's 1 every 5 images, well, that's just a tax on your observing time. You've got to take more pictures until you get one that's good. But as the number of satellites increases to the point where you get multiple streaks per image, then it becomes really hard to correct for this problem, and you stop being able to do certain kinds of science. And so I think on although it's at the moment, it's at the level of a nuisance. 10 years from now, if the number of satellites increases as predicted, it could rise to the point where, yeah, there's significant kinds of, there's some science we can still do, but there's significant kinds of science that's going to get very difficult to do from ground-based telescopes.
Well, that brings me to the Vera Rubin Space Telescope and its survey. It's surveying the entire southern sky, and it is expected to lose part of its data to satellite streaks. How serious is that impact? I mean, we just spent a lot of money, and we're going to taking a deep look at the universe. What might we lose?
Yeah, no, it's not great, Dave. So, I mean, the Rubin folks have been working closely with SpaceX to mitigate this issue. SpaceX, to their credit, have done a lot of work in making their satellites fainter, in changing how they operate the satellites so it doesn't reflect data down into Rubin. But then you've got the Chinese constellations coming on board. And they're bright, and they're not doing these mitigations, and they're in high orbits, which is the worst for Rubin's data. And so we don't really know yet how bad it's going to be, but it could potentially be very bad. And particularly for things like, for example, one of the places astronomers love to look is a nearby galaxy called the Large Magellanic Cloud, which is in the southern hemisphere. It's up overhead from where Rubin is in midsummer, and midsummer is exactly when you have the worst problem for the sun's not that far below the horizon. The satellites going overhead can still see the sun when you can't, and so they're illuminated all through the night. And so the data for the Large Magellanic Cloud is going to be crisscrossed by these streaks. It's already a very complex field with gas clouds and everything. And so adding to that complexity with spurious streaks is just going to make the data really, really hard to analyze and maybe intractable. So I'm pretty worried about that. I'm also worried about the search for near-Earth asteroids that could actually hit the Earth. It would be very embarrassing if we missed one because there was a satellite streak in the crucial image that confused the detection software. And so, and so I think, although I don't want to overstate it, there will be some kind, if you're doing like a very narrow focused image on one particular galaxy, and you don't need a lot of sky, and you don't need a very long exposure, then you'll be fine. But there are serious kinds of astronomy, and particularly some of the survey work that Rubin does, that could be very significantly affected. And we're scrambling to figure out how to best address that.
So, staying with the environmental impact theory, what's the footprint of building, launching, and replacing thousands of these satellites? We're using up our rare earth metals. They're being burned up as they fall back in. What other kind of issues are we going to face as this continues to increase?
Right. So you've got the effect on the lower atmosphere, the stratosphere, during the rocket launch. You've got the effect on the upper atmosphere from the reentries. You've got the collision risk in Earth orbit. You've got the light pollution issue, and as I say, you're basically using up a lot of precious materials as well. And so I think we've reached the point where the environmental impact of space activities is no longer negligible. And you used to be able to go, oh yeah, it's small compared to everything else we're doing, and you can't say that anymore. And so yeah, I think we have to be more mindful of the aggregate environmental cost of space launch and space activities.
Okay, so is it worth the risk to reward? Is that worth it?
I mean, I think in the big picture, we have so much to gain from space exploration that you don't want to give that up, right? The question is not, should we do it or not? The question is, how can we explore and use space and have successful commercial development of space in a sustainable way that allows us to successfully deploy these space systems, but also not screw up the environment while we're doing it. And so I do believe that a middle ground can be found, but it will require some degree of regulation on the part of governments to balance the ambitions of the space companies.
Right. Okay, so I guess let's come down to our finality. If you could set one rule for how humanity should use low Earth orbit, what would it be?
The one rule for low Earth orbit, is, I would say, ambitiously but sustainably.
Okay. And I suppose you'd like to elaborate on that as well. Why don't you give us a fuller picture?
Yeah. And so I think we're going to have international coordination of the environmental impact. We're going to have allocations of particular orbits for particular countries and companies. We're going to have to limit the brightness or the number of satellites above a certain brightness. We're going to have to limit the number of reentries a day. We may have to have an alternative approach to disposing of your satellites, possibly involving recycling their materials in orbit. And we're going to have much better international coordination of orbital maneuvers and helping make sure that things don't run into one another. And so all of those things, right, require particularly, and one of the big developments of the past decade has been not just the commercialization of the Western space programs, but the commercialization of the Chinese space program. So you have all these Chinese startups launching satellites as well as the Chinese government. We desperately need coordination between the Western side and the Chinese side because space is intrinsically global. A per country solution just isn't going to cut it in the long term. And so I think that international conversation on how to bring the benefits of space to people on Earth, which are real, while not messing up the environment. And so in particular, I just want to mention about some of the benefits. I mean, we have, obviously GPS is something everyone uses, but a lot of people use other space technology without even realizing it. Internet of Things devices that flow their data over satellites, tracking systems like where's my airplane that my friend is on right now, or where's my FedEx package, all of that. Using data funneled through satellites. Our knowledge of climate change, a lot of it is from NASA climate change satellites. Weather forecasting, obviously. All of these things involving observing the environment, observing the Earth, communicating with each other, machines communicating with other machines. Space is an intrinsic part of that information economy that we now live in, and so I do want to emphasize that is a good thing. It enables a lot of things on our world that are improvements, and so we have to figure out how to do that with maximum advantage, but balanced with protection of the environment.
Well said. Well said. I can't disagree with any of that. Jonathan, it is always a pleasure to talk to you, sir. My friend, you've given us a lot to consider here. In the meantime, where can people keep up with what you're doing at your space report? Jonathan's Tell us about that. Where do people go?
Right.
And I will
So
add these URLs in the description of the video, so you don't have to memorize these right now. They'll be in the
All right.
description.
Yeah. And so I have since 1989 been doing a newsletter on space activities, supplemented now by a website with the list of all the rocket launches and social media feeds in which I rant on about what's happening in space. And so the website is planet4589.org. And you can find it also by Googling Jonathan's Space Report. And you can find me on Twitter and Blue Sky as @planet4589.
Got it. Okay. And remember, folks, those links will be in the description, so you can go and join the space community. Get your foot in the door. Jonathan, thank you so much, folks. Thanks for watching. I bet you got something out of this one. This certainly gave you something to think about, and we will see you next time right here on EarthSky. Thank you so much for joining us. Go give us a like, subscribe to the channel if you haven't already. Visit us at earthsky.org. One Earth, one sky, EarthSky. Thanks for being here, folks.